Okay, hello everyone. You're welcome to episode 3. We're still in New General Mathematics for SS1, chapter 1. So, in our previous video, we tried to list the four topics in chapter 1 that you expected to know. So, if you've not seen that video, please do well. So, this is the second one we've dealt with indices in episode 2. So, in episode 3, we're looking at standard form. And what is standard form? Standard form is a special way of writing numbers, whether large numbers or small numbers. So in this form, a times 10 to the power of what? N. So a times 10 to the power of n. So this is a special way of, so once a number where your a is was an element of what? 1 less than equal to a less than 10. That is to tell you that a falls between the range of 1 to 9. So 1 to 9. That is a is a unit number. It's the front number must always be in unit form. That is the meaning of this. So if you have it in tens or hundreds, it's not standard until it is placed as a unit number, right? Example, if I have 3 times 10 to the power of 2. Now, 3 is units, right? Because it falls, unit numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So once you've started pairing, it becomes 10. So it must be units. So this is standard form. Now, but if you have it as 4, 3 times 10 to the power of anything is no longer a standard form because there is a problem here. 43 is not a unit, it's not in unit, it's in tens. Even if you have it as 4, 4, 5, 6.2 times 10 to the power of 3. So it's not standard yet, even though there's decimal point, because this is 456 points, so it's on hundreds. So because that's the integers we have here is hundreds. So, but all these ones are not standard forms. They are not standard forms. It's only this. It has to be in units. So, what if it is like? So, what do we do if we are asked to write tens or hundreds or even units in standard form? What do we do? We must always bear in mind that every number you have has an invisible decimal point. Every whole number without decimal point has an invisible decimal point at the end of it. Just like we have naira something kobo. So if you're writing, so when we get to that bridge, you will see it. So if we are to write, let's say 5 in standard form, what do we do? We will multiply 5 times, you know, 10. Now, like I told you, we have decimal point at the end of every number, point zero. So if that point zero cross outside, it has nobody, it's not crossing over anything. So it becomes zero here. So 5 times 10 to the power 0 is 1. Remember, another way to see this is that since we have only single number here, we multiply it by 1. And anything 10 to the power 1, 10 to the power 0 is 1, according to our indices. So, but what of if it is now two numbers like 25, but in standard form? This is where your work come. So you always remember that 25 without decimal point has an invisible decimal point at the end of 25, which is what? 25.0, right? 25.0 is something as 25.0. So according to standard form, this is not, you cannot write it as 25 times 10, right? Because it's more than that. So what we're going to do is that we're going to move our decimal point here to this side. So how many times did you move? Once. So that will give you 0.2.5 times. So since you move once, here will increase to 1. So that counting, as you're moving, you're adding it to the power of 10. So doing it this way, you've written it in standard form. So let's go again. Let's say I have 3, 4, 5. In standard form will be what? Remember to say, and just bear it in mind. At a point, you will stop doing this because you have it in your mind that you are counting backward. There's an invisible decimal point here, so you're counting 1, 2. So you have 2. So this is 3.45 times 10 raised to the power 2. If you notice, each of those answers, the values are in unit because this is 3.2 points, so they are all in unit. So and so on and so forth. Now, this actually is what we are referring to as large numbers because large numbers are non-zero leading numbers. All non-zero leading numbers are seen as large numbers. While leading zero numbers that are leading that has a leading zero, they are known as small numbers. So in such numbers, what do we do? Example, when you have zero leading numbers, like for example 0.3, and you want to write it in standard form, here is zero leading number. Zero is leading a number. So in that case, our power must be negative. So how do we solve this problem? So remember, our rule is that the our rule for standard form is that the front number must be in units. So since I have only one number here, I have 3 times 10. How many leading zeros do we have here? One leading zeros, minus 1. So if I have uh, if I have 0.04 and you ask to write in standard form, then the same thing goes. How many leading zeros do we have here? We have two leading zeros. So we have 4 times 10 minus 2. So on and so forth. It continue that way. Two leading zeros. So if it is three leading zeros, it continue that in that order. Okay, what of if it is no longer, if we have something like 0.0045 and you are to write in standard form, the rule still remain the same, that the your front number must be in units. So in that case, we have 4.5. The point, this point must return to this place. 4.5 times 10. So here you're counting only leading zeros. How many do you have here? You have minus. You have three. So you have three leading zeros. So it continues that in that order. Now let's look at standard form problems. Like the problem is in standard form and you're asked to multiply, add, divide, you know, divide, add, subtract, do whatever you want to do. So how do we work around something like that? For example, let's say I have number one, I have a times 10 to the power of n, right, plus a times plus what? B times 10 to the power of what? M. So what do we do here? What's the answer? Now, here we have plus, right? Here we have plus. So now this particular A will you add to this and this will add to this directly because we just move in that way. So we have here, we have A plus B in brackets times what? 10 to the power of N plus 10 raised to the power of what? M. So you can just add them that way. That's the rule number one for standard form, right? Now number two, if it is subtraction, it's still the same thing. So for plus and minus, it's still the same thing you have to do there. For plus and minus, it's still the same thing you have to do there. If it is minus, you are still going to do the same thing. If it is plus, you're still going to do the same thing. Now, what of if it is multiplication? Let's say I have a, right, times 10 to the power of n, right, yeah, times b times 10 to the power of what? M. So what do we do? Situation like that, it's still the same thing. A will multiply this and this will multiply this. So that will give us A times B, then times A times B. That is this times here. Then times, because we have two times, so collect one. Then I'll get what? 10n times 10m. So when you do this, you will have according to indices, you can add the top side. So here we'll be having AB, right, times 10 to the power of what? N plus M. So for division, still the same thing. For division, if I have A times B divided by, sorry, not A times B. So for division, it's still the same thing. For division, it's still the same thing. Let's say I have A times 10 to the power of N divided by B times 10 to the power of what? M. So you still need to this divide by this. You have A divided by b, then times what? 10n divided by 10 what? n. So still the same thing. So you can divide them. Remember, according to indices, you subtract the power, then right, a divided by b. So and so on and so forth. So please take note of all these things because questions like this will be asked. You should not find it difficult to solve. Okay, what of situation where I have a divided by 10n, then divide by b divided by 10m. So what do we do? You take the same thing, you multiply this to this, you have a divided by b, then divide by what? 10n divided by 10m. We're going to solve a problem like that. So you see an example. So in this case, so for this, we have it as a over b divided by what? Here I have 10n minus m, right? So now this is not standard. Remember, our target is to make it standard. So we have to change this into what? To multiplication. So what do? We have a over b times, right, 1 all over 10 n minus m. So if you're changing this as multiplication, you have to take the inverse of your right hand. Remember your fraction. Hope you remember the rule in your fraction. So that will give us a over b times 1 all over 10, right? Okay, let me just put it there. I have 10 minus in brackets n minus m. I hope you remember because I told you in indices that 1 over this means minus. I hope you remember that. So here we have what? A over b times minus, open the bracket here. I have minus n plus m. So here my answer is a over b equal to what? 10 minus n plus m, something as what? M minus n. So the answer is a over b times what? M minus 10. So please take note of all these things. We're going to be solving problem the next, when we are done explaining all these things, we're going to solve problems. So if you don't understand, pause the video and play it back again and see. And if you have any question, please drop it at the comment section so I can attend to it. If you're new to this channel, do well to like, subscribe, and share. And if you have anybody that is in SS1 or your children, please share this video with them so that they'll begin to learn. And those of them that are in SS3 too, let them begin to learn general mathematics because this is what they're going to see when they go to SS1. I will do well to make sure I explain everything here